Let me guess. You're tired of seeing those seemingly impossible SAT math questions that look nothing like what you practiced. Well, don't worry, because today I'm going to be going over 5 of the absolute hardest math questions from real past SATs and giving you solutions from a 1600 scorer.
So looking at question number 1, the wording is a little tricky, but when we understand it, it's actually very simple. So we have the mass of object A is 416% of the mass of object B. We want to think of it as an equal sign. So on the left side, we have the mass of object A, then we have is the equal sign, and then 416% of the mass of object B. When we're going from a percent to a decimal, we divide by 100, so we get A equals 4.16 B, or you can say A is 4.16 times B. For our second equation, we have the mass of object A is 0.064% of the mass of object C. So A by itself is 0.0, but then we divide by 100, so we add 2 zeros, we get 0.00064 multiplied by C. Now that we have these two base equations, so let's look at what they're asking us. If the mass of object C is P% of the mass of object B, what is the value of P over 1000? So once again, there's some tricky wording, but if we do is right here in the middle, we know the left side of our equation has to have the mass of object C, and the right side has to have P% of the mass of object B. So what this means is we want to get C by itself, and first let's look that both of these equations are equal to A, and therefore both of these values are equal to each other. So 4.16b is equal to 0.00064c. From there, we know that we want to get C by itself, so let's divide both sides by 0.00064, and we can do that with Desmos. When we do that, we're going to get 6,500. So that means that we're going to have 6,500 multiplied by B is equal to C by itself. But we want to make this a percent, and so in order to fulfill this percent that they're asking here, we would multiply any decimal by 100 to get the actual percent. So looking here, we multiply this by 100, we get 650,000. So C is actually equal to 650,000% of B. Now, we're not just done yet because this is P%. So we know that P is equal to 650,000, but they're not asking us for P. They're asking us for P divided by 1,000. And so finally, for our last step, 650,000 divided by 1,000, and we're going to get 650 as our final answer.
Alright, moving on to question 2. We're given this quadratic equation and we need to find the constant k based on the sum of the solutions. So anytime you hear sum of the solutions on the SAT, think negative b over a. Here, the numbers are given to us on a silver platter as the a term, the b term, and the c term are separated from your x squared, x, and c. So now we're given that negative b over a, the sum of the solutions, is going to be this expression. So negative b over a equals all of this right here, 21a k times 21a minus 35b. So now if we were to put that in writing, what would it look like? Well, it would look something like this. You have your negative b term over here after you apply the negative to the 9a squared minus 25b squared, so the signs flip, and then you have your a term right here and your whatever your negative b over a is equal to. So now that we got here, what do? Well, the SAT is all about pattern recognition and making the process as simplified as possible because you're not trying to do a lot of work. So when you look into this problem, what patterns can you recognize? Well, if you look closely, you can see that all the coefficients associated with the a term are divisible by 3, and all the coefficients associated with the b term are divisible by 7. So if we were to use that to advantage, what would it look like? Well, if you scroll down here, this is what you get after completely expanding all these equations. And how did I get from here to here? Well, on the top, I used difference of squares to get to this. On the bottom, right here, I divided by 2, so I got 2 times 5b plus 3a. And then inside of these parentheses right here, I took a 7 out. I took the GCF of 7 out, put that next to the k, and that left me with 3a minus 5b. And now, our goal is to isolate k and get a solution from there. And to do that, we need to cancel all these terms out. So once you cancel all these terms out, you get something like this. And to show you the process of what I did, I started off by canceling these out because they are inherently the same term. And now I'd be left with negative 3a minus 5b over 2 equals all this. So the next step is to multiply this side by 2. So get rid of the 2 in the denominator right here and make that 14k. And now we want to isolate wherever k is, so we're going to take this whole 3a minus 5b term right here, and then we are going to divide it on this side. So negative 3a minus 5b, take that, 3a minus 5b, then all that is going to be 14k. So if you cancel these out, you're just left with negative 1 because a negative is going to apply. Negative 1 equals 14k, and then you're just going to divide by 14 to isolate for k, and you get your solution. Negative 1 over 14 is k.
So now let's take a look at question number 3. And once again, we've got some pretty big, scary looking numbers, but if you know your algebra skills, you can do this really fast. So we've written out the equation right here, and without looking at the answer choices, let's actually try to solve it. And our first step is going to be multiplying everything by 3x cubed, which is our denominator here. And what that's going to do is on the left side of the equation, it's going to remove our denominators, and on the right side, it's just going to multiply, right? So on the left side, we have x to the power of 27 times x minus 7 plus 7x to the power of 27. And now it equals 3x cubed multiplied by what we originally had, which is 1/3 x to the power of k. Okay, so when we multiply these, we have to be very careful. We know that this 3 here and this 1/3 here are going to cancel out, and so we're really going to get x to the power of 3 times x to the power of k. And when we multiply these with the same base but different exponents, we actually add the exponents, and you have to remember that because that is really important. So now we've got this essentially equal to x to the power of k plus 3. And on the left side, now when we distribute these values, we get x to the power of 27 times x, which is x to the power of 28, then minus 7x to the power of 27, and then plus 7x to the power of 27. So this entire part of the equation right here is going to cancel out because we have negative and then positive of the same value. And when we cancel that out, what we're going to end up with is down here, x to the power of 28 is equal to x to the power of k plus 3. And when we have this same base, what we can actually do is just cross out the base and say 28 is equal to k plus 3. And so 25 is equal to k. Let's go up, and our answer is going to be C, 25.
All right, moving on to the Desmos portion of it. This problem does require a lot of the work we did in the previous problem. So if we go take a look here, we still need to identify each of these solutions and set them all equal to 154. But where Desmos helps you is it tells you what k is instead of you having to solve it on your own. So if we were just to put all of that right here, 11 times negative square root 5k plus 10, and then that times square roots 5k plus 10, regression sign, 154. And as you can see, you get 12 for k. So simplifies the process, but you have to understand how the problem works on its own before using Desmos to help you.
Alright guys, so y'all are doing great so far, but let's look at the final hardest question. The function q is defined by q of x equals this entire equation, where a and b are constants and a is greater than b, which is greater than 87. If q of 639 is equal to h and q of negative 621 is equal to k, where h and k are constants, what is the value of all of this plus all of this? So we're given so much information and so many numbers, it can get really confusing. A lot of people will even skip this question, but you can do this really fast. First of all, you don't need to do anything with a and b because you're all not actually going to need those numbers or that inequality. Instead, do what they're giving you, which is q of 639. So plug in 639 as x into this equation. When you do that, this is what you're going to get: a times absolute value of 639 minus 9 whole squared minus 87 times 639 minus 9 plus b. Now, when we actually subtract 9, we get a times the absolute value of 630 whole squared minus 87 times the absolute value of 630 plus b. Now let's plug in the second part, which is plugging in negative 621 as x. When we do that, what we're going to end up with after all the plugging in is this equation. And now we know that this equation is equal to q of negative 621, and it's also going to be equal to k. And then we know that this equation up here is equal to q of 630 and also h. So what is the relationship? Well, if we zoom out, we can actually see these are the same value, right? The absolute value of negative 630 and the absolute value of positive 630 are the same value. And so these two equations actually are the exact same, right? They're both a times the absolute value of 630 whole squared minus 87 times the absolute value of 630 plus b, which means h and k are actually equal to each other. That's going to help us out a lot. So here they ask, what is the value of 9 times negative 639 to the power of h minus k? Well, if you subtract anything from itself, which in this case is happening because h and k are equal to each other, you're going to get 0. And so we have 9 times negative 639 to the power of 0 plus 621 times 9 to the power of 0. Now, when you do something to the power of 0, you get 1. So we have 9 from this side of the equation. We have 9 times 1. And from the right side of the equation, we have 621 times 1. So with simple math, we know that 9 plus 621 is 630. And so that is actually going to be our final answer to this very complex looking question.